Everyone. My name is Kanwar Bharat Singh. Today I'll introduce TechRAG, an evidence-gated multimodal agentic RAG system designed for technical literature review. I'll discuss the problem that motivated this work, then explain the architecture, the key design choices I made, the evaluation results for this application, and finally the future roadmap. So let's start by understanding the problem. Today, answering a complex technical question often requires researchers to search, read, compare, synthesize information from hundreds, if not thousands, of papers. And as you can imagine, this process takes days or even weeks. The challenge really goes beyond finding documents. Researchers must reconcile conflicting results, interpret text, figures, tables, equations, and verify that every conclusion is supported by reliable evidence. That's a lot of work to do. Because of this complexity, manual literature review is difficult to scale, and missed or unsupported evidence can lead to incorrect conclusions and poor engineering decisions. For those of us who work in the research and development community and setup, you can very well appreciate and empathize with this problem. So, what would be the ideal state, and what should the future look like? My vision was to build an AI research assistant that could search, analyze, synthesize, and validate evidence across large technical document collections. That vision became TechRAG. TechRAG turns weeks of manual literature review into hours of AI assisted evidence backed synthesis. It does not just generate answers, it retrieves evidence, maps citations, validates claims, and provides transparent, traceable results. When I was building this application, I really had the following personas in mind: researchers, R&D teams, patent analysts, technical product managers, everybody who needs fast answers that they can trust. Trust built through retrieval grounding, reliability engineering, observability, and multi-layered guardrails. Now, the obvious question is, why not just use a standard LLM or a traditional RAG system? Well, if you think about the nature of research, technical research, it's inherently multifaceted, and that's the reason an agentic system becomes a good use case here. A researcher, when he's looking at a technical subject, must break down the question, look at evidences, judge the evidences, compare conflicting papers. So a single pass LLM cannot do all of this in a reliable manner. And TechRAG approaches this problem like a research team, uh, wherein specialized agents can handle planning, retrieval, synthesis, critique, and adaptive decision making. The division of labor really makes the final response more reliable and consistently backed by evidence. So, in a nutshell, the agentic system really brings the consistency, the reliability, which is key when you do research which might have implications on certain safety critical use cases. Here's an overall architecture of the system. Looking from left to right, as you can see, it's an end to end orchestration starting from the user input. Now, as I was thinking of this application, one has to be mindful about in a real world, you often have situations where you have promptware, what's coming to be known as promptware. So you have to make sure you have guardrails at the input, which you see there. That's what I've implemented, wherein you can check for PII, prompt injection, and other issues that are largely being discussed now. Once you're sure that the input is safe, then you run your retrieval orchestration layer. It's a multimodal retrieval architecture built, includes text retrieval, Neo4j knowledge graph database, and also a visual retrieval pipeline. Since we are looking at technical papers, it includes text, but it also includes images, equations. Once you have your evidence retrieved and validated, you run it through a multi-agent generation process to generate the response. And finally, before presenting that to the user, you see there's evidence validation gate, wherein you check for evidence sufficiency, citations, check there are no hallucinations, and return the answer to the user. On the next slide, we see the implementation details and how I built this as a layered architecture. The foundation is a multimodal knowledge layer with about 2600 technical papers indexed using vectors, knowledge graphs, visual embeddings. Above that, you can see the retrieval layer. What was quite interesting for me is also to explore the visual retrieval path using call Pali. Very powerful, I must say, wherein we can also just not understand text but look at figures, tables, and charts. And above that is the multi agent framework. In this case, I used OpenAI GPT to plan, retrieve, synthesize, and critique the answers. And finally, as I said, thinking of a production-oriented system, one has to think about all the guardrails and also observability. In this case, I am Rise Phoenix libraries along with telemetry, open telemetry to make sure there's full evaluation, observability, and monitoring. And the key design principle, of course, is modularity. Each layer has been designed in a manner where you can upgrade. Let's say if I want to upgrade the LLM or if I want to upgrade one of the guardrails, it's been designed to be fully modular. I want to highlight a couple other key design choices. I think since this is really built for engineering, research, and development application, at the core is an evidence gating system wherein this is a hybrid system which uses a 100-point evidence sufficiency score system, looking at the confidence of the evidence that's being retrieved, specificity, diversity, metadata quality, recency, and finally running that through also an LLM as a judge. And all of that, what it essentially makes sure is that you've got a mechanism to rate what is the retrieved information, the quality of the retrieved information, and decide if that's enough or you want to rely on some external sources like academic papers. So as you can see, depending on the score, there are different paths that the router might take, wherein in one case it might generate based on what's available in the corpus, or in other cases it might do other searches to make sure the coverage is maximal. The second innovation is the multi-agent collaboration. Instead of relying on one LLM to handle the entire workflow, TechRAG divides the process into four agents. The planner creates a research plan, the researcher retrieves and maps evidence, and the writer produces a citation-backed answer. Finally, the critique reviews it for accuracy, completeness, and citation quality. So at every stage, the response remains grounded in retrieved evidence, making the final output traceable and citation supported. And as you can see, this very much mirrors how human research teams would work, leading to more accurate, structured, and trustworthy answers. To evaluate the RAG, I used 40 representative technical research queries covering literature synthesis, technical comparisons, bibliometric analysis, multimodal reasoning, and it fared quite well. Overall, the retrieval quality is high, the evidence scores were high, the guardrails ensured there was no leak of information, there were no zero off topic responses. And in terms of overall execution time, it's roughly about 2.5 minutes, going from a user entering his request to generating a response, and the cost is around anywhere between 1 to 2 cents. I'll conclude with key learnings. TechRAG shows, agentic AI is really well suited for technical literature review by combining hybrid retrieval, agents, and evidence validation. Multi-agent collaboration really helped improve the citation quality, the trustworthiness compared to a single pass generation. And in terms of next steps, really includes, further architecture tweaks where I can reduce the latency. As I said, it's 2.5 minutes right now to retrieve, synthesize, and produce the final response. So there's definitely some opportunities for parallelism and then also expanding the evaluation. So overall, TechRAG is a strong foundation for trustworthy AI-assisted technical research. And just as closing reflections, by combining hybrid retrieval, specialized agents, guardrails, it really does produce answers that are verifiable. And the goal really is not to replace researchers, but to help them spend less time searching and more time creating new knowledge. So yes, the future of AI is not just generating answers; it's generating answers that people trust. And before I conclude, I'd like to mention the work is fully documented in an archive preprint paper. The paper provides complete technical details, including system architecture, implementation, pipeline details. So please do look it up. With that, we will transition to a quick demo of the tool. This is a demonstration of the TechRAG app. As you can see, the user can come in here and enter questions under ask. Stop an instance. Initiates the application where it starts to first understanding of the intent. This is a content-based search. It's a rewrite of the query to improve retrieval. Thereafter it goes through the retrieval path, looking at semantic search, graph-based search, visual search. Looks at all the evidence and does an evidence sufficiency check. Also then looks at external sources and references to see if there are additional papers available. Creates augmented prompt. So let's go and actually see what came back from the retrieval path. As you can see here, these are results from the local RAG. There are results from external sources that retrieved. These are results from the knowledge graph. These are results from the visual retrieval path. It combines into the augmented prompt, which is shown here, which includes all the evidences. There's also built-in applications for complete traceability using Phoenix Arise and also guardrails using guardrails.ai. Go back here and see right now augmented prompt has been sent to the multi-agent system to generate the answer. Researcher, writer, and a critic. Getting the response. It's going through an agentic loop. So you see the final output here being available. This is the rubric that was actually used to determine the quality of the evidence. It's a hybrid system which is rule-based, using at these attributes, but also the final determination made by an LLM. For instance, if the rule-based system says there's enough evidence, but the LLM says it's weak, it goes and does an external search. It looks like it finally ran. This is now total cost to run. It's tracking the total cost for each call. And I can go and see actually the response. So this is the final response. This was the question that the user asked. And this is the response it generated based on